Hello, and welcome to our Lab 4. This week we're going to focus on the normal distribution, which is going to be used quite often for pretty much the rest of the quarter. The normal distribution is unimodal, symmetric, it has kind of a bell shape to it, and is used throughout statistics. A lot of variables like SAT scores, heights, anything that has a lot of data tends to follow the normal distribution pretty closely. And as I mentioned, most of the work we'll be doing for the rest of the quarter assumes that our point estimates come from a normal distribution. So to make sure our conclusions are valid, we need to verify our conditions. So we need to check that the normal distribution is a reasonable assumption. For us, we will have three methods to check the assumption of normality. And these are pretty quick, especially with R. The first is a histogram, and the idea with the histogram is just to see, does it look unimodal, more or less symmetric? We don't have to be absolutely perfect, but is it reasonably unimodal symmetric? And you can see it in the left panel over there, in the left panel on the screen, there's a histogram. It somewhat follows the bell shape. This is a pretty good histogram. The sample mean and standard deviation are used. Basically, you can see the curve in the background, which is a normal curve. We use the mean and standard deviation of the histogram in order to get that curve. And the closer this curve fits the histogram, the more reasonable the normal model assumption. A second method, as you can see on the graph on the right, and that's a normal probability plot. And essentially, the closer these points follow a line, and the line's usually drawn, the more confident we can be that the data are normal. Now, here are three sets, just to kind of give you an idea of what kind of look for. One is a fairly small data set of 40. The middle one is a data set of 100. And the one on the right is a data set that deals with 400. And you can see that as the sample size increases, these histograms and the normal probability plots tend to look better and better. The histograms look more and more unimodal symmetric. The probability plots tend to look straighter. All these, the points more or less, follow the line just kind of a little bit above and below, but as the sample size increases, we get better and better results. And here are some histograms and probability plots you will typically see for different types of distributions. A unimodal symmetric distribution is the ideal one. You can see that for symmetric, it's generally unimodal symmetric. It looks more or less, bell-shaped. The probability plot looks very much like a straight line. This is sort of the gold standard. This is what we love to see. Below that is a distribution that is heavily right-skewed. This is one we don't want to see. I mean, it really complicates things anyway. You see the histogram is very right-skewed. The probability plot will show a very strong bend upwards. Left skewed is also something we don't want to see. And you can see there's sort of a bend down, on the left is bending downwards. Those bends are what we don't really want to see. That's the indication that's not normal. Bimodal, that's two peaks. It'll have the curve will be an S curve. Also not normal, though bimodal generally is not too much of an issue. The skewed graphs are issues. Also an issue is that later on the quarter we'll be dealing with small data sets. And for small data sets, histograms and probability plots don't really work very well. The best we can usually do is just to make sure there's no outliers. So a third method we'll be looking at, especially for small data sets, is to look at z-scores for the minimum and maximum. You'll get a range of where the z-scores are going from. For the most part, we want the z-scores to be between -3 and +3, and anything beyond those values will be considered to be outliers. As far as commands go in R, the big 3 commands this week, the hist command will give you a histogram. The QQ-norm command will give you a probability plot, and QQ-line will add a line to the probability plot, so it's a little easier to assess. And as far as z-scores, what you do is you first define your variable, and then we'll go ahead and say z is equal to x minus the mean divided by the standard deviation, and then we'll run the summary command of those z-scores. The summary command will give you the minimum and maximum, median, mean, quartiles, but it'll give you the range of the value of the z-scores. It's a quick and easy way of seeing if your values are all within that -3 to +3.